Hey guys, welcome back, and today we're going to be talking about 2.4, which is solving by taking square roots. And for our warm-up here, I just have solve x squared plus 3x equals 2x plus 12 for x. And this is kind of just to jog our memory, but what I would actually want to do to this is I would want to set one side equal to 0, and I preferably want my x squared to be positive. So I'm going to subtract this 2x over, and then I'd get x squared 2x, or 3x minus 2x is just 1x, which is the same thing as x, equals, that's gone, and then I still have 12. Well, now I also want to get that 12 over, and so now I have x squared plus x minus 12, and then 12 minus 12 is 0. And then from here, here we could factor. It's going to be x, and x, because x times x is x squared. And then I need two numbers that multiply to that last number, negative 12, and add to that middle number 1. There's an invisible 1 there. And the two numbers that I could do that are going to be positive 4 and negative 3. So I stick positive 4, negative 3 into there. And then to solve these, remember we drew this line down the middle and we set both sides equal to 0. Then we just solve for x. So to solve for x here, all we do is subtract 4 over. We get x equals negative 4. And then here we just add 3 over to get x equals 3. And those are our two answers. And these make sense, right? Because if x is negative 4, this is that zero product property we use. If x is negative 4 plus 4 is 0, times, it doesn't even matter what this is 0. So that statement's true. Same thing here. If x is 3 minus 3 is 0, times, it doesn't even matter what this is going to be 0. And so that was just a reminder of that's one way that we solve these quadratics. Quadratics meaning something with x squared. And today we're going to be looking at a different way to do it, and that's by taking square roots. So just a quick refresher, we should remember our perfect squares here. Something squared means times itself, right? So 1 squared means 1 times 1, which is 1. 2 squared means 2 times 2, which is 4. 3 squared means 3 times 3, which is 9. 4 times 4 is 16. 5 squared is 25. 6 squared is 6 times 6 is 36, and so on, right? 12 times 12 is 144, so 12 squared is 144. So taking square roots is going the other way. So the square root of 121 is actually 11, right? Because 11 squared is 121. So if we were to undo that, right? If we were to take the square root of 121, the square root and the square kind of cancel out, and we're just left with 11. And then a quick rule that we have here that you probably went over in Integrated Math 1, but we need to remember, if we have the square root of a number times another number, you can split that up into two different square roots multiplied together, or you could also go the other way around, right? If you have two that are split up together, you could also put them all under the same root multiplied together. And so one example, if we had to simplify the square root of 18, well, I could say 18 is the same thing as 9 times 2, right? 9 times 2 is 18. And then we can, this rule right here, right? 9 times 2. If we have x times y, this time it's 9 times 2. We can split that up into the square root of 9 times the square root of 2, just like this rule says. And then we know that the square root of 9 is 3, since 3 squared is 9. And then that square root of 2 just stays there because the square root of 2 is nothing nice, and it can't split up any further. Right? And another way I like to think about it, I kind of like to bypass this step. So if I can just think that 18 is the square root of 9 times 2, I can just say, okay, that 9 can come out as a 3. And then what's left is that square root of 2. And so here is probably the most important thing about today. This is like the thing that you want to write down or pay attention to the most. Whenever we take the square root of a variable, we have to add plus or minus to one side. Now why? So let's take a look at x squared minus 16. I'm actually going to write it further out here. Or x squared equals 16, right? So one way to get rid of squares, right, is take the square root. Just like here, if I take the square root, that kind of gets rid of that squared, right? Because the square root of 121 is 11. So taking a square root gets rid of the squared, and I'm going to do it here too, but now I'm going to do just what I said. I need to add plus or minus. That's what that little symbol is, plus or minus. And so then I'll get x equals plus or minus 4, which really means I have two answers. It means I have positive 4, and it also means that I have negative 4. That's what that means. And why do I have to add plus or minus? Well, let's think about it. If x equals negative 4, then plugging it back into this original equation, wouldn't negative 4 squared be 16? Right? Negative 4 times negative 4 is positive 16. And the same thing if we just have 4 squared. Right? So both of these answers work. And that's why we have to take that plus or minus, because when you have something squared, it always turns positive no matter what. So adding this plus or minus takes into account this negative here. That's a possibility. So now it's just a bunch of examples. And for each of these, my trick is to get whatever it is that is squared by itself, right? So I see x squared is by itself, or I see x squared. I see that the only thing that's squared is this x, so I want to get this x squared by itself. The first thing I would do is probably add 4 to both sides, and then I'll be left with 2 times x squared minus 8. Those cancel. Negative 8 plus 4 is going to be negative 4. You can distribute this too and then do some stuff, but I'm just going to divide by 2. So then I'm just left with x squared minus 8. Negative 4 divided by 2 is negative 2. And then I'm going to add 8 over. So then I get x squared. Those are gone. Negative 2 plus 8 equals 6. And now I can just take the square root. But whenever I take the square root, remember I have to add plus or minus. So then I get x equals plus or minus, and then the square root of 6 doesn't break down into anything nice, so that's exactly how we would leave it for Delta Math. And Delta Math does have a plus or minus button you could use, or if you are comfortable, we just have a positive square root of 6 and a negative square root of 6, right? And you could write both of those out, do that thing where you make two different answers by hitting a comma or that plus button on Delta Math, and you could write it like that, or you can use that plus or minus. So for this one, 11 minus 2x squared equals 5. Again, it's just the x that's squared, so let me get that by itself. I'm going to subtract this 11 over. So I'm going to be left with, because those are going to go away, negative 2x squared equals 5 minus 11 is going to be negative 6. And then to get this x squared alone, I'm multiplying by negative 2, so to get rid of that, I should divide by negative 2. And then I'm left with x squared equals negative divided by negative is positive, 6 divided by 2 is 3. And now that square root of x squared is just alone, so just take the square root now. Whenever I take the square root, I have to put plus or minus. The square root of x squared is just x, which is the whole point. And then we just have plus minus the square root of 3. Square root of 3 doesn't break up, so you would just leave it like that. And again, or you could write it out. You could say, hey, one answer is positive square root of 3, and the other answer is negative square root of 3. You could write two different answers, or Delta Math has that plus or minus button for you that you could use if you want to try it. This time, remember how I said you want to get whatever it is squared alone. This time it's this whole chunk that's squared, right? It's x plus 10, the entire thing x plus 10. So I want to get that big chunk of stuff all by itself. So first I'm going to subtract 14, and then I'm going to be left with 4 times x plus 10 squared. 14's cancel. 26 minus 14, 20 minus 10, 26 minus 10 is going to be 16, and then 16 minus 4 is going to be 12. Then we're going to divide by 4. So then I just have x plus 10, that whole thing squared. 12 divided by 4 is 3. And again, now that I have this whole thing squared, this one gets a little tricky, but now I could take the square root, right? Whenever I take the square root, I have to do plus or minus. Have to do plus or minus. So from here, then the squared goes away, and we're just left with x plus 10. And then we have plus or minus the square root of 3. So now we're not done. Now we need to subtract this 10 from both sides to get x by itself. So then we get x equals negative 10 plus or minus the square root of 3. And you could write that, or again, you could split it up. You could say x is negative 10 plus the square root of 3, or x is negative 10 minus the square root of 3. Okay, let's do one more here. Again, it's this giant chunk squared, right? So let's get that whole thing alone. Let's add 46 to both sides. And then I'm going to be left with 4 times 2x minus 4 squared equals 56. I'm going to divide everything by 4. So then I'm left with 2x minus 4 squared equals 56 divided by 4 is going to be 14. And then because 4 times 10 is 40, and then we need another 16 after that, and 4 times 4 is 16, so together 10 plus 4 is 14. And then we could take the square root. Now that we have it by itself, whenever we take a square root, we need to add plus or minus. So now all that's left, the square root and this square cancel out, and we're just left with 2x minus 4 equals plus or minus the square root of 14. I'm going to add 4 over. So now I get 2x equals 4 plus or minus the square root of 14, which again, square root of 14 doesn't split up nicely at all. But now I need to divide by 2. So that I'm going to have x equals 4 plus or minus the square root of 14 all over 2. And you could write that in delta math, but you'd have to be careful. You're going to have to put parentheses around this so that when you divide it, it's the whole thing. Otherwise, what you could do is this is the same thing as x equals 4 over 2 plus or minus the square root of 14 over 2, right? Because when you add or subtract fractions, all you do is go across the top, but you leave the denominator the same. And you know 4 divided by 2 is 2, and you have plus or minus square root of 14 over 2, which if you wanted to write it as 2 different answers, you could write 2 plus the square root of 14 over 2, and then x equals 2 minus square root of 14. It's supposed to be a 4. 14 over 2. You could do that, but I think that just leaves room for more error, so I would just do it like this and just make sure that you have everything divided by 2 when you type it into Delta Math. But that is going to wrap it up for this lesson. It was pretty quick, but it was kind of filled with information. So, just be careful with what you're doing. Remember to add that plus or minus every single time. And it's also good to note that this is just another way to solve quadratics, right? Just like in the beginning, how We've solved it using the zero product property before. This is just another way to solve, right? It's just a different way to find the same answers.